So what's the effect of overwatering? I mean, a number of factors. But let me stop first and ask you a question. It's Saturday morning. There are a lot of good cooking shows on the TV or home improvement shows. What made you want to come here to learn about irrigation? Well, you heard there was food. Okay, good. Coffee, right? I have a question back here. Okay, we always learn something new by coming to these kind of meetings. Yes? Overwatering, underwatering, that's a good point. So we'll talk about some of that.
I heard we were getting wine samples at break. But aside that, I have problems with the pressure regulation on my drip.
Okay, so things about pressure regulation, especially as it relates to drip.
There's a lot of runoff, and I know the state laws couldn't get it back when I
Okay, so addressing runoff, good. Well, that's what I'm going to be talking about today, so you came to the right place. So let's talk about problems with overwatering. When we overwater, it affects our plants. Plants die if they are overwatered. You track pests. Major cause of plant death is overwatering. It adds time and labor to maintain the site. And you know, it's just, the runoff is bad, and it's just poor public relations. So the leading causes of wasted water in irrigation is an improper design, install, or maintain system. Most of the time our systems aren't maintained. Inefficient systems with outdated technologies. So I'm going to be talking about the newer technologies today. Incorrect pressure, we had that question over here. Incorrect pressure or flow, things like water applied faster than the soil can absorb it. You know, the system just not adjusted for our current landscape. We put it in at the time we installed fresh plants. Now the plants are growing up. Now the sprinklers are hitting it. Problem. So let's meet your irrigation system. So basically there's different components of the system. We're going to take a deeper dive into each of those. But basically in smaller areas, we're going to use a sprinkler type that's called it's called a sprinkler or fixed spray sprinkler. They usually either have a fan spray on top or they can rotate. They might have a bigger distance, a distance like 20 to 40 feet, where we might have a single leg rotor that rotates. Mostly in California, we don't have too many yards that are that big, but maybe a big backyard, you might want to have a rotor. We're going to have something that works with a controller or timer, and then we operate that with a valve. So when you look at your yard, depending on how many valves you have, that's how many stations you need on the controller. So we'll take a deeper dive into each of these categories. Now, what I wanted to start with first is a video of the common problems. Now, the video is older. I did this about 8-9 years ago. So there are some things they talk about that have changed. So it was tied to a program we did with Rancho Water in Temecula. And in their program, they gave out these little catch cans. You're not getting catch cans today, but if you save 2 cans, you can get the same effect of measuring your efficiency in your sprinkler system and just a workaround. But I think it gives you, it's 90% there. I will, through the conversation, talk about some of the things like you saw that in the video. Most of the stuff is pretty solid of what you're going to do as you look to make improvements.
Everyone enjoys a beautiful landscape, but keeping your lawn and plants healthy takes regular watering. One of the easiest ways to do this is with an automatic underground irrigation system. You control exactly when, where, and how much water is applied, ensuring that you water as efficiently as possible. But did you know irrigation systems need to be properly installed and maintained? If not, they can waste a lot of precious water. This short video will show you how to look at your irrigation system and determine how efficiently it's watering. You'll learn how to spot potential water wasting problems and take care of them. When you're done, you'll have a super water efficient system that will keep your landscape green and healthy. Let's get started. First, you need to thoroughly inspect all the components of your system. Let's start with the valves. Each area of your yard, or zone, is turned on and off with a sprinkler valve. You may have anti-siphon valves that are above ground, or you may use inline valves that are usually located underground in a valve box. Valves are often near each other, close to your irrigation controller, but your valves may be in different areas around your yard. Once you locate all your valves, do a quick inspection for leaks with the system off. They should be dry with no visible water leaking out. You'll need to check each valve for proper operation. Turn the solenoid on the top of the valve about a quarter turn until its zone begins to water. Make sure there are no leaks at the valve while it is running. Don't worry, it's common for a little water to come out when you first turn it on. To turn the valve off, twist the solenoid back the other way until it's tight again. If any of your valves are leaking, there are several things you can do. Just make sure to turn off the main water supply to the irrigation system before you attempt to fix a valve. You may need to disassemble and clean the valve. You may have to tighten the connection to the pipe, or it might be time to replace a valve. Check the valve manufacturer's website for tips. Next, go to your controller. Most controllers allow you to manually turn on each zone. Activate each zone one at a time and let it run for about a minute. Make sure they come on and turn off. This is also a good time to write down exactly what each zone waters in your yard. Next, take a look around your yard. Soft, wet ground or a large puddle may indicate that you have a broken or leaking pipe. If that's the case, you'll need to dig a bit to find the leak and repair it. Also, keep an eye out for brown spots, or spots where the grass is much greener or taller than the rest of your yard. Take note of these areas. We'll look at reasons for that later. It's time to inspect your sprinklers. Once again, turn on each zone. Check for any missing or broken sprinkler heads. You may need to replace some. Also, make sure every head on a zone is the same basic type of sprinkler. There are fixed pattern pop-up sprays and rotating sprinklers. All of the heads on a zone must be the same type. You should never mix sprays with rotating sprinklers, for example, since they water at different rates. Change out any sprinklers that don't match the others on that zone. Look at the sprinkler heads and make sure they are not buried too deep or raised too high. The top of the head should be flush or slightly higher than the ground. Make sure the heads are not tilted. When popped up, they should be straight and perpendicular to the ground. If not, dig around each head and straighten it. Each sprinkler head should pop up and have a strong spray pattern. If some don't pop up all the way or spray properly, you may have too many heads on that zone. Your water pressure or flow rate might not be strong enough to run that many sprinklers at the same time. On the other hand, if you see misting or fogging, you may have high water pressure and need to install a pressure regulator. Inspect each head to make sure it is pointed in the right direction and the pattern is correct. Check the distance each head is watering. Most sprinklers allow you to adjust their distance as well as their pattern. Check the manufacturer's website for tips on how to make these adjustments. If a sprinkler head is not working properly, the nozzle may need to be cleaned or replaced, or the entire head may need to be changed out with a new one. The next piece of the puzzle is your irrigation controller. This is the brains of your system. It controls when and how long each zone waters. There are many different types and manufacturers of controllers. Make sure you understand how to program yours. Instruction manuals are usually available from the manufacturer's websites. First, go to your controller and make sure the correct date and time is set. Some controllers save their information when the power goes out by using a battery. If your controller has a battery, it's a good idea to replace it every 6 months. Next, make sure each zone is programmed the way you want it to run. Most controllers use a multiple program, or ABC system. Each program can be set to water multiple zones in your yard. For example, Program A may control the watering for your lawn. Program B may handle the trees and shrubs, and Program C may do the vegetable garden. Each program will have its own start times and days, and any single zone can be included in each program. Make sure you understand the way your controller works. This is where a lot of water can be wasted if you program your controller incorrectly. A good place to get tips on how long and how often to run each zone is from your local university extension. Some irrigation manufacturers also have runtime calculators on their websites. You might not realize it, but many sprinkler controllers already contain some easy-to-use water-saving features. Some things to look for include 1. A rain shutoff device. Almost any controller can have a rain shutoff device attached to it. This automatically prevents the system from watering when it's raining. 2. If you don't have a rain shutoff device, many controllers allow you to temporarily suspend watering during rainy days. By activating the rain delay feature, you can stop watering for up to several days. Then the system automatically returns to its normal watering schedule. 3. Many controllers have a handy seasonal adjustment feature. This allows you to quickly adjust your watering times up or down, depending on the season, without changing any part of your program. For example, if it is unusually warm outside, you may want to water 20% more than normal, but still water on the same days and times as before. Now that the system has been tuned up and inspected, let's run it and see how it's doing. As part of your outdoor water savings kit, you received 5 small plastic cups with measuring gauges printed on the side. Use these to check how evenly your system is watering. Choose one of the watering zones on your system. Place the cups around the zone, spacing them evenly across the whole area. It may be necessary to test each zone several times, moving the cups around the area until you have tested the entire space. Turn on the zone where the cups are placed and run it for about 5 minutes. After you shut the zone off, take a look at the amount of water in each cup. They should hold about the same amount of water. If some of the cups are dry or have significantly more water, then your system is watering unevenly and you could be wasting water. Repeat this process for each zone in your system. If your system is not watering evenly, review all of the steps in this video and make sure you have fixed all of the problems that you can correct yourself. If it's still not watering evenly, your system may not have been designed properly. Many manufacturers provide a free sprinkler system design service. Give them a basic drawing of your yard and some other basic information, and they'll send back a detailed sprinkler plan. Try requesting one of these free designs and comparing it to your actual system. It may give you ideas about changes you need to make to be more efficient. A professional irrigation contractor is also a great resource to help you get your system up to peak performance. A good contractor can perform a more extensive system check and take care of the maintenance items we talked about earlier. Thank you for your interest in saving water and taking steps to make your automatic irrigation system as efficient as possible.
So a lot of this information is in your book, page 89 to 94. So a great reference by using the book. Going back to the website and watching videos like this are also very helpful. Now I'm going to be talking about 6 key strategies or technologies that we can use in saving water in our landscape. The first area that we're going to talk about is the controller and going to a smart weather-based irrigation controller. The next area we're going to talk about is this idea of flow sensing or leak detection. That's really critical. It uses a lot of water if you have a break in your line. The third area is pressure regulation. Optimal pressure for your irrigation is going to be a saving factor. And then looking at high efficiency nozzles and that definition. Another big area we can save is in going from sprays to drip irrigation, particularly in the planter areas. You know, usually the home builder gave us sprays in that planter section, but converting that to drip will save, and I'll talk about that. And then my favorite topic is the maintain, troubleshoot, and repair. You know, it's the fun and the fundamentals of irrigation. So let's start with the controller. So let's discuss controllers first. How many people, when I say controller, think of that box that's usually in the garage? So are you thinking controller? How many people think of timer? Some controller, timer, clock? Okay, so for this group, all those terms are the same thing and mean the same thing. I'll use the word controller, but I might use timer just to switch it up, but I'm saying the same thing. So as we said, timer is the brains of irrigation. I've been using that for probably the last 25, 26 years. So it's obvious as my presentation has it and the script and the video had it as well. And basically it tells the system what days to operate, what time to operate, turn on, and how long to water. And most of the time, they're either an option of indoor or outdoor. Now, to program the controller, we need to know what time is it now. We need to know what time do you want to start watering. And on the controller cabinet, it might say start time. And then it wants to know how long do you want it to water. The controller might say run time. Now, what are run times? That's really answering the question, how long do I need to run the system? So it's a specific amount of time to run each valve. Now, to calculate that is based on a term called scheduling. And I took 8 hours of scheduling. I mean, you can really get into details with scheduling. But basically, some of the factors that go into that is sprinkler type, because it talks about how much water is going down on the site. Soil type. Now, soil type is really interesting. And think of soil as being like a sponge. I brought some sponges with me. So this sponge, which is like Mr. Magic sponge, is really dense. So if this was a soil type, what kind of soil type do you think it might be? Clay, yes. Now, this one is very porous. So that might be sandy, okay? And then this third one kind of be in the middle. In reality, there are lots of different soil types, but if you think of it as a kind of extreme, if I was looking at a triangle, you would have kind of this idea of either sandy or, you know, clay or, you know, kind of a loam type, or most of the soils are probably somewhere in the middle. And that has to do with how much the water can be absorbed. Now think about it, if it was sandy soil and I put water on it, what's it gonna do? It's gonna go straight down. So I might have to water less time, but you know, more, but frequently. If I was doing clay, I couldn't water very long at all. In fact, you could probably get runoff in like 4 or 5 minutes because it's just running off. So that's part of the scheduling factor. And then the idea of the plant type. The plant type is really the root depth. So, you know, grasses may be 4 or 6 inches, but a native plant may be 6 or 9 to 12 inches. A tree may be longer. So that's going to affect where we're going to be our runtime as well, our scheduling. And if the system's not efficient, you're forced to run it longer to kind of compensate. So you can use catch cans, and that's the example in this picture, or you could use tuna cans, but basically you're trying to just check to see how efficient it is. And you can also tell as well, because when you're looking at your grass, if you get brown spots, you know, you're not getting the coverage that you need. So here's some scheduling tips, and this came directly from the book. Don't water at the same amount of time all year round. Temperatures are changing. Water early in the morning. In fact, there are usually regulations that say you have to be done by 8 a.m. Try cutting back on watering days rather than shortening run times. And then know your soil type, and you're going to watch for runoff. So your first homework assignment. You're going to take out a pad of paper and a pen. You're going to use the stopwatch feature on your phone. And then you're going to run each valve one by one, and you're going to record the minutes when you see runoff. So in clay soil, you may see runoff in 4 minutes. That is possible. And you're going to watch it, and you're going to write that down. And what you're going to do then is reprogram your controller for for that time. So clay soil, 4 minutes, then I need to give it only 4 minutes. Now, if it was a really hot day, I might give it an additional 4 minutes. But giving it 8 minutes when I had runoff at 4 doesn't make sense. And that's why the suggestion to eliminate days is a better way to go. Make sense? Homework assignment. Now we're going to take a deeper dive into water savings. The best water savings device is a smart weather-based irrigation controller. I'm going to come back to that in a minute. A couple other ideas are soil moisture sensors. I'll talk about that. Rain shutoff devices, the rain delay water budgeting feature, and this idea of cycle and soak. We're going to take a deeper dive. These are the less effective, the idea of a rain shutoff device. Now, your irrigation should not be running when it's raining. For the price of dinner out, you can get yourself a wired or wireless rain sensor and add that to your system. Usually the rain sensors from any manufacturer works with any manufacturer's controller. So that's easy. You don't have to be specific to yours, so you can buy one. But I would definitely recommend, as a minimum, you get a device like that. Then there are features like rain delay. And as in the video explained, you walk out to your controller and say, do not water for so many days. 2 to 3 days is a good way to go. And then after that time, the controller will come back on. Some other features are this idea of water budgeting, and sometimes it's called seasonal adjust, kind of the same terms for the same idea that allows you to adjust your run times by increasing or decreasing. It still doesn't give you that benefit of not watering days you don't need to water, but it's helpful. And most controllers, basic controllers, have these features. And we want to do something where we're applying water and, waiting, stopping, and then if we need to come back, we water again. So that's either a feature on the controller, cycle and soak, and it's recommended for slopes or compacted soils. Another way you can work around that is multiple start times. So if it's really hot, you come on for the 4 minutes, it continues going through all the other valves, comes back on again, and gives it another 4 minutes. Yes?
I have a controller that's about 20 years old. It seems to be efficient, but should I invest in a newer one?
I would recommend investing in a smart weather-based controller, and I'm going to talk about that now. Basically, they can save 30 to 40% because you're over, watering when you don't need to be. So that's a great introduction to weather-based controllers. And basically, weather-based controllers use factors like rain, wind, humidity, temperature, and evaporation. And we're basically replacing the water that's lost through evaporation and transpiration from the plant. We put those two terms together, and we use the word evapotranspiration, or ET. So smart weather-based controller are also ET-based controllers. So what is ET? It's basically converting inches of water lost through the plant, and that's how we're going to translate that for the controller. We want to include in there rainfall, irrigation from the skies. So the factors that go into ET are solar radiation, and that's the most important one. Let's think about this. November, at Thanksgiving, it was 93 degrees, right? Last week, it was about 93 degrees, not today. But the amount of daylight in November was like 10 hours. We are now almost at 14 hours. So you're going to get a lot more evaporation. Okay, so solar radiation is the most important factor. Temperature obviously affects us, wind and humidity. And then we want to count back for rainfall if we can use that. And then where that's important is how we actually are managing our watering. As horticulturists, we talk about the term deep and frequent watering, and this is where this idea comes into play. If I had my sponges here, and I put a lot of water on it, and now the water is running off my sponge, that would be an example of saturation. That's too much water. Okay. So as time goes on, we get, water is evaporated, and we get to this optimal place. We call that field capacity. Now, we're going days without watering. What we don't want to happen is go so long that the plants die as a permanent wilt point. Okay, that's too far. So we want to fill it up to a level, that's field capacity, and then go days without watering. And then, in a sense, like a gas tank, we're going to fill it up again. And that's the irrigation amount. So the idea of deeper frequent watering, and this is kind of explaining why if we can water for 4 minutes, you give it the 4 minutes, and then you try and go days without watering again. So this is an example of an on-site weather sensor. So it's a controller, and it has its own little station. So let me give you some real-world examples. I mentioned that you could save water with these things. Depending on how frequently you're watering, then you're going to save a lot more water. So I have a very efficient irrigation system. Well, yeah, I get the products for free, of course. So I had efficient irrigation, high-efficiency nozzles, and I knew how important it is to go in and change your irrigation system schedule. I probably was doing it every about 3 weeks as weather was changing, I was making changes. How many people change their irrigation every 3 or 4 weeks? How many, let me go back the other way. How many people change it once a year? Okay, or twice a year? A couple times, 4 times a year? Okay, we're getting a little better here, okay. The fact is we're not changing it as much as we can, and that's where the savings come in. So I was going out there making changes to my controller and then put in this weather-based controller. And I saw 20% water savings that year. Really? Yeah. So there were days I was watering when I didn't need to. And that example is that 90-degree day in November versus in, in May, the solar radiation. So I should have been not watering, in the wintertime as much. Now, on the newer technologies in the marketplace are these Wi-Fi enabled controllers. So I brought some examples of those. That's where you're using internet, like your iPad or iPhone, tablets, and you're able to either control it at the controller or see weather from a weather source, and it runs your irrigation system. So those are kind of your 2 options. Now, there is another approach, and it is called soil moisture monitoring. And basically, I'm going to show that to you. Oops, let me go back. Now, intuitively, it makes sense. Soil moisture, you have a little device in the ground. It senses if it's wet or not and doesn't allow irrigation. But it doesn't work as well as weather-based. Like, this works great in ag, and the technology is very sound. It's been around for a long time, and in ag world, it's been very useful. When you think about ag, you're talking about acres and acres and acres of the same plant material. You don't have the neighbor's house, you don't have trees, you don't have other things blocking it. So weather-based tends to be a better way to go. But on the bright side, there are rebates for these things. So taking advantage of rebates at SoCal WaterSmart is a great way to go. The rebate generically is about $80 a controller, so it helps. Some water districts will put in additional funds, so you just have to check your water agency. Or when you go to SoCal WaterSmart and you go to the controller rebate, then you put in your address and it kind of knows what the, it kind of knows what the, what your rebate would be. So if there is additional fees, and that's great to know. So in summary of technology 1, weather-based controllers, the first thing you could do is program your controller carefully. Consider additional controller features, and then upgrade to a weather-based controller. That's going to be your biggest bang for the buck. Let me stop here. We talked about controllers. What kind of questions do we have? Okay, I have a question in the back. Yeah, so that is going to be the downside to the Wi-Fi, is that that is a situation where if you have the rain device on site, it'll know your rain. And then those rain devices like that actually figure out how much rain you had and calculate that into the controller. So then the controller says, oh, well, we had half an inch of rain. I don't have to water for another couple days. So that's kind of the nice feature. A lot of folks really like the convenience of the phone. And I had another question on controllers.
I just wanted to say that last year I got one of these weather-based controllers, and it may rain a few drops, and it says, do you want to delay 24 hours? And on my phone, I don't even have to go to my controller to program or anything. On my phone, I say, no, I need the rain tomorrow. It only gave me 3 drops. So you can get one of those.
Yeah, so that's the benefit of the Wi-Fi, that you're able to use your phone. Another question.
So I have an old controller, and all I do is raining outside, I turn it off. So how much of an advantage these new technologies offer over my brain?
Okay, so yes. So, you know, that's a very valid question. If I am turning off the controller, particularly people who turn it off all winter long, then you may not see as much water savings as a person that is running it 3 days a week all year round, 3 in the winter and 5 in the summer. But you know, for the most part, you are going to see water savings.
Can I just give a plug? With the Western Municipal Water District rebate, mine was almost free. So the cost shouldn't be too much of a factor. If you look on the website, then you can get it for free or almost free.
Okay, question?
Can the average person switch them out pretty easily?
Yes, so to switch out a controller is very easy. What I recommend is before you take it out, you know which one is in the valve 1 slot and which one's in the valve 2, 3. Masking tape, write down 1 and say 1 is front yard, 2 is side front yard, 3 is back, whatever it is. And that way, when you take out the controller, you know what those wires are. You put the controller back in and you put the 1 in the 1 slot, 2 in the 2 slot, and then it's always going to be where you want it to be. So you're not confused. It's like, oh, why is that coming on? No, I have where I had 1 coming in where it's supposed to turn on. So pretty straightforward. Now our next area of improvement is in this flow sensing and leak detection area. So I'm asking you to be a leak detector, and just as you saw in the video of while you're using that time to see when you're going to see for runoff, use that time as well to look for either drooling at the lower heads, puddling in areas. Another important area is if it's supposed to be watering on your grass and it's watering on your driveway, you'll need to make that correction. Okay, and sometimes that's very easy. A mower might twist it around a little bit. So while you're looking for runoff, use that time to also look for some of these heads in the right spot. Look for heads that, you know, have as a plant material in front of it. You know, so use that 4 minutes or 5 minutes while you're looking for runoff to do that sort of thing. Now, what I also recommend is you read the water meter with all the faucets and water use appliances off. And basically, you're going to look at the meter and see if that it's spinning, and it shouldn't be spinning. If no one's running water, then it should not be spinning. If it is spinning, then that means you have a problem. So we're going to take a deeper dive into water savings. Our first area, well, we'll talk about Wi-Fi water meters. We'll talk about submeters and check valves. So, you know, it would be perfect in a perfect world that your water agency has smart meters and installs it for you, and then you can go online and look at your water use, and they can send you alerts to say, you know, looks like you had a higher water use situation. And so that technology is coming. You know, I'm not sure which water agency you're with, but that technology is definitely on its way. We'll have to check with the folks here at Western to see if they know where it's at. But this is an example. So it's using cellular or Wi-Fi kind of internet type of thing. And it's installed by the meter. And then you're able to get that information off your phone. You can go to your website and track and see what's going on your yard. Then there are devices like actually flow sensors, and that's that top picture. And this is something that a lot of cities and big commercial sites use. Basically, the top picture has a little paddle wheel. And the controller learns that it's supposed to put out, let's say, 50 gallons per minute. So it's a big zone. We're running rotors. And it sees 50 gallons, and then a sprinkler gets broken. And now it's seeing 75 or 100. Well, the paddle wheel is spinning faster, and it sends a signal to the controller, and the controller says, turn off, and now send an email to the person managing the system to say, oh, we had a problem on valve 3. Okay, really cool, huh? So I have this system at my house, of course. And I have the software to do all that technology. And I'm going to tell you a real life story. In my backyard, basically it's a patio with lots of drip around it. It had learned it was supposed to see 6 gallons per minute. And one day it saw 8. So it sent an email, and that's pretty alarming. So I did what anybody who's been in irrigation for 26 years does. I sent my husband out and said, I think there's a line, something broken. And he did the repair. I was making dinner. So, so that kind of technology is out there, but with these smart meters coming into play, that'll really help you with that same situation. Another device that you can also do, some apartment buildings will use like a sub-meter, and that's an example of that blue one. That's basically a sub-meter, and the contractor reads these, the water usage and records it, and that's how that's handled. Now, this is something everyone can do. So let's think about, you think about your landscape, and usually there's a little slope, a tiny slope, not much, going to the driveway. Would you agree? That there's a section that's a little higher and then goes to the driveway. So we have our hits here, and the last one tends to drool. It just drools out. How many people have seen that? Okay, so what is happening is that it is literally drooling out. And what we can do to prevent that is putting in a check valve. Let me show it to you. A check valve in the bottom of the sprinkler. I will pass these around in just a minute because I want to talk about 2 features. But this then keeps the water in the pipes, and you don't get that drooling. And that's something you can all do. If you can change a light bulb, you can change out to these features. Now, these features are not at Home Depot or Lowe's or those kind of stores. You actually need to go to a professional irrigation house. So examples of irrigation houses, you can Google it, look it up, but like Ewing Irrigation is really close to here. Site One is another name. Imperial Sprinkler Supply, Smith Pipe. So they're all over Riverside, San Bernardino County, I mean all over, especially in Southern California. So you can find a place, professional house, and you're going to ask for a check valve. So you take a picture of your sprinkler, the manufacturer, and then you say, hey, I need the check valve feature. Rainbow calls it a SAM feature. So the price of, so basically if you can remove, change a light bulb, you take out, you leave this in the ground, and then you drop in this new featured product. Question here.
Doesn't it just go to the next lowest head?
No, it'll keep drooling. If you go to, you have to change them all out.
Okay, that's what I was going to
Yeah.
say. Or it just goes to the next lowest
It just goes, yeah, so you have to change everything out, all of them. Okay. So leak detection. We want to eliminate leaks. So that's why it makes sense to check your irrigation, on a seasonal basis. Walk, look for things, make sure that they're just aligned right. Look for the check valve feature. It doesn't add that much cost to buy those features. I would say, if a regular sprinkler is $2 and this is maybe like $5. I mean, so it's not that much more money to get this water-saving feature.
Excuse me.
Yes.
On that check valve feature, you say you have to change them on all of them. You can't, not just the last one, you have to have them on each one.
Yeah, because it'll steep. So if you put it in the last one, then the one next to it is going to start leaking out. You have to change them all out. And then the last thing I would recommend is that you ask your agency, your water agency, if they have smart meters available or when they're coming to your area. Let me stop here and talk about, see what kind of questions we have on leak detection. Check valve feature, definitely a good way to go. Definitely do the walking around and looking for leaks. I mean, that's a lot of water. Question over here.
Yeah. If you have taper off to your driveway,
Mhm.
and you have the rest of it at the same level, why couldn't you just change the low one? Because the water is not gonna run out where the other ones are at the higher level.
Okay, so the question is, why do you really have to change them all out? Because when the ones at the higher level, it's probably true that maybe the ones at the top level, let's say the 3 are top, and then you start leveling, then there's 3 or 4 that are going down. So you may be able to get away with just changing something that's on an angle, but normally we recommend you change, it's just common industry, you change them all out to check valve. And there's another benefit to that, and that is that the pipes stay filled with water. When you're draining out, so we're draining out, we're not keeping the pipes full, they're just going to continue leaking out. So then when you can get air into the line, so then when you turn on the system again, now you're pushing air, so you get a little more of a water hammer. So when you have check valves in all your heads, it keeps water in all the pipes, no leaking out any of the heads. Okay, leak. This is another important area, pressure regulation, and we're really talking about optimal pressure. So when we see pressure that's really high, like this looks like a cappuccino machine, okay, then this is definitely an example of high. You can also hear it kind of has a hissing sound. You can also have the problem of low pressure, and then you get what is known in the industry as donuts, because you're just not putting enough water down. So the only way around this is either putting in more valves and having less heads on the zone, or you might have to go to a booster pump. So as parks have converted to recycled water, the park was used to seeing 80 pounds per square inch, 80 PSI, and then they went to recycle, now it's 50. So very common that the park will bring in a booster pump, bring it back to its optimal level, and then eliminates these donuts. But, okay, so most of us don't need a booster pump for our house. So what we can do is look at pressure regulation. We can either do it at the valve or at the house, or we can do it in the sprinkler body. It is actually more efficient to do it in the sprinkler body. So let me tell you about some research that was done. Metropolitan Water District has a grant program called the Innovative Conservation Program. And they awarded a grant to study through the University of Arizona third-party pressure regulation. And the test was set up so that we looked at 4 valves of sprays without pressure regulation, 4 with, and we also did 4 rotors with pressure regulation, 4 without. And then we ran it. The sprays were ran at 30, at 45, and at 60 PSI. So what kind of difference do you think you would have seen in all the 4 zones versus the other 4 zones at 30 PSI? Well, there really wasn't much, because they're regulated at 30. So they basically didn't show much of a difference, except we did have improved performance. There was less misting, so you could actually take your timer and run it shorter because you had a little more efficient system. But as we increased to 45 and at 60, was really using a lot more water. And even though it was a blind study, you could see the reports and know that that was definitely a difference. It came out to be something like a gallon per minute per head. That's a lot for just being 20 PSI over the optimal range.
So 30 is the optimal.
30 for the fan sprays, and 40 to 45 for the rotating. And we found that same study with the rotors as well. So basically, for every 5 PSI reduction, you're reducing water use by 6 to 8%. And you can get those in the sprinkler bodies themselves. I'm showing you some examples of high flow. So in the body itself, another device, now I'll go ahead and start passing these around, is a pressure regulator at the stem. That's like in the sprinkler body is the most efficient, so every head is very efficient. A cheaper way to do it is you could do pressure regulation at the house, but then you still have, as your heads are out in the area, they're not going to be optimal pressure, so you really want it in every head. So it is a little device like this. So this is the SAM feature or check valve feature, and this is the pressure regulation here. So same thing, you leave the body in the ground, and then you just remove the old innards, put in the new innards, take a picture of the head so that you can take it to a professional irrigation house and then get you the right bodies for your existing sprinklers.
So that clear body that you have in your right hand there, that is your existing body that stays in the ground.
Yes.
The only thing, you're not getting into any of that plumbing.
No, I don't. That makes life so much easier. Yeah. Okay. I'm going to go ahead and pass that around. Question?
Is there a simple way to test your pressure existing?
Yes, there are pressure gauges that you can buy. And you can go to a professional irrigation house, they'll have a gauge, and they can help you do this little assembly where you remove the thread, you put this little gauge on, you put the nozzle back on, and then you test it, and you can see your pressure. But you can also tell you have high pressure. It makes a sound. It looks misty. Now, you can kind of do something to fool pressure regulation. If it's not too bad, then you can go back to the valve and some valves, this is an example of a low flow valve, but some valves have a component in the center called a flow control, and you can dial it just a little bit, and you'll see the heads get less misty. You know, I like to say that's like a fine tune.
Will that affect, if you fine tune this one, is that going to affect any of the other heads on that line?
So on the lines, you're going to put pressure regulation in all the heads. Yeah, you're going to take the check valve out, and you're going to put check valve and pressure regulator in all the heads on that zone. So pressure regulating devices, optimal pressure, really key. I mean, really, a gallon per minute per head, just being 20 PSI over the recommended amount, that's a big deal. Now, our fourth area is this idea of high efficiency nozzles. So there are two kinds of high efficiency nozzles for our sprinkler bodies. We can either have a fan spray or we can have rotating. And the rotators do really well in slopes and clay situations. And the fan sprays, if they're high efficiency fan sprays, do great if you have wind coming up, because you're going to put them down, the water down, let's say in 4 or 5 minutes, it waters, you go to the next valve, and you get your whole water window done in just like 30 minutes. So high wind, sometimes the fan spray is better. And there are rebates for these kinds of things. So if it's on a rebate list, it's a high efficiency nozzle. So when we think about it, what we're looking for are large water droplets. We want good close-in watering, so good watering from the head to the next head. And we want even distribution. And there's 2 terms for that. One term is an industry term called distribution uniformity. And that's really going back to those tuna cans. And you're setting them out in the yard, and then you're going to water, let's say, for 10 minutes. And then you can use a yardstick, well, you know, a little stick, 12-inch, and you measure and you see where the water comes up. And maybe it says puts in 1 inch. In a perfect world, all those cans would have 1 inch. If one has 1 inch and one has a ½ an inch, then you can tell you have a problem. I took a 2-day class on doing this. It was really interesting. But it was really, even though intuitively it makes sense, if you've got the plants in the way, or you don't have even coverage, then you're going to have more brown spots and you're going to overwater to compensate for that. Now, the next term came from the ag environment, and that is called application efficiency. So if this is where I want to water, then if for some reason wind caused it to water over here, then I'm not on the place that's supposed to be watering. So in a perfect world, we want to have each can be even, and we want to make sure that we're watering where we want to water. So those are 2 terms that they look at. That's the definition of high efficiency. So in summary, high efficiency nozzles, if you're going to take the time to replace the head, you might as well change out the nozzles. Same manufacturer, so you don't want to have different manufacturers of one and different on the same zone. Same manufacturer on that zone, and either fan spray or the rotating. We want to make sure we have head-to-head coverage, the head from one going the head to the other. And there are rebates on these kind of nozzles. It's about $2. Some places maybe a little bit more, but it's normally about $2. So it kind of covers some of that cost. Let me see if there are questions about high efficiency nozzles. How many people think they could do something like this? Change out the bodies and change out the nozzles? Good, 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 good.
Is the bottom part that the nozzle goes into, that's in the ground?
Yeah.
Are those the same, are those interchangeable from manufacturer to manufacturer? No, the other part.
No. So that's why you want to keep a picture of your manufacturer, and then you get the innards for that manufacturer. They're not interchangeable.
Do all the manufacturers have the same features?
Yes, all the manufacturers have a check valve and pressure regulator. That's pretty well industry standard. And in fact, I wouldn't be surprised if down the road that just becomes what's required, and that you're not even going to have the option of buying them without the features. So then at that point, it would be available. I'll see if there are any other questions, and this would be a perfect time to take a break. I wanted to tell you about one other thing. At the end of our session today, there'll be raffle gifts, door prizes that you'll be able to win. And then I also have, at the end, so people can go home if they want to, but I have samples of drip fittings and emitters and tools, and so if you want to stay and kind of play with some things, I'm happy to stay here and answer your questions specific to your yard at that point, or if you want to play with some of the tools, because you'll find out that some of these tools make it so much easier than installing fittings. If you've ever installed fittings, it's hard. If you've ever installed emitters, that's hard unless you have tools. So I'm going to show you some stuff at the end. It'll be after the door prizes. So take a look. We're going to take a 10 minutes. We'll be back here around 11:10, and we'll continue. So when we think about drip irrigation, there are other terms that apply to this. Another term I've used and heard is micro irrigation. Another one is low volume irrigation. Or even when we talk about drip irrigation, we could be also talking about drip, so emitters, but we're also talking about things like micro sprays and micro bubblers. So let me just ask this question. How many, when I talk about drip irrigation, think of the whole category? Do you call it drip irrigation? Or somebody said drip irritation? No, I thought that was funny. Drip irrigation, so that's pretty common. People talk about micro irrigation. Do you think of micro? Okay. Low volume? Not too much. Okay, so we're talking about this whole family of, all the components that go for a drip irrigation system, but it could be like micro sprays as well. And it's precise amount of water at the root, helps reduce weeds and plant disease, helps eliminate runoff, and drip irrigation is very forgiving. You can have bigger plants, smaller plants, dense planting, sparse planting, and it works together. So why use drip irrigation? Well, we can eliminate things like stain fences, water spots on windows, water spots on vehicles, foliage, being blocked, asphalt damage, and liability. I mean, if you're part of a homeowner association and you're getting this constant asphalt damage, most likely your dues are going to have to help pay for some of that repair. So if we can eliminate that, we're going to keep things stronger and healthier. Drip is also very beneficial in that we can match the application for each plant. So very forgiving. Bigger plants, give them more emitters. Smaller plants, give them just a few emitters. We can match the application rate, soil infrastructure, applying directly at the root zone. We're not overspraying, and could be like 90% efficient. So here's an example of 2 minutes versus something like 15 minutes from sprays to drip. Now, when we think about drip irrigation, there are two areas we have to keep in mind. The first one is, what is our planting plan? Is that planting sparse? And by that I mean, are the plants very distinct, and are they 3 or 4 or 5 feet apart from each other? Think about the desert installs. They're very distinct in the plants. They're not right next to each other. That's considered sparse. And we're going to irrigate that using what's called point source. I'm going to take this in more detail in a minute. We got sparse planting, and then we have our next one is dense planting. Is a ground cover. Are the plants all together? Are they really close together? In that technique, we're going to do something more like a drip grid, a drip line kind of system. We're going to grid that whole area, water that whole thing. Now, when we think about drip irrigation versus conventional, our flow rates change. So when we're doing regular sprinklers, we're measuring that in gallons per minute. So if I had this jug and I put a nozzle on it, in 1 minute, gallon per minute, I'd fill up the whole gallon jug. With drip, we're talking about gallons per hour. So I got my jug, and you'd be sitting here watching me for the next hour because it's dripping. So think about that. You have these little orifices in your emitters. So they don't like high pressure. They like somewhere between 15, 40 to 40 pounds per square inch. How many of you have had the experience where you have the drip system running and then your pressure is high and things fall off the lines? Okay, hot pressure too high. So you definitely want a system that reduces the pressure somewhere about 50 psi, 40 psi. And you're dealing with these small emitters, so we want to have a filter on it. And somewhere around 200 mesh, kind of your optimal, catches a lot of good stuff. Now, there are a number of components in a drip system. Did I have a question?
Yeah, I was just wondering, is that similar to a soaker hose too?
Okay, so a soaker hose, if I'm understanding your, or verifying the definition, there were hoses that were out there made from tire and they just leaked. Those clogged within a very short amount of time. Some people refer to a soaker hose now, but it really should be called drip line, where they come with factory installed emitters. And the emitters are spaced like every 12 inches. This is 12-inch spacing. They could be 18 inches, but most time I recommend 12-inch spacing, and I recommend the highest flow rate, which is usually about 9 or 1 gallon, 0.9 or 1 gallon per minute. And that way it's very easy to figure out how to schedule your controller for that. So they're factory installed emitters. Okay, so we don't call that soaker hose, we call that drip line. Okay, yes, question?
Can you have in the same zone a sprinkler and a dripping system?
You cannot really have sprinklers and drip in the same zone. They should be separate. We have basic components. So when you go to the aisle, like at Home Depot, or you go to a professional irrigation house, they'll have displays of product. And I've seen people go to those displays, and there's so many things that the eyes roll back of their head. And that's the contractors. So I've broken it down for you to make it really easy. We're going to start with a category of components called control zone components. And that's kind of your valve, filter, regulator, working very well with your controller. Then we're going to distribute the components. We're going to take it from our water source to the different emitters. And it could be different types of tubing. It could be PVC, like this example. It could be the tubing itself, could be distribution. It could be blank tubing. And then we have our emission devices. It could be emitters that we're going to punch in for point source, or it could be factory installed emitters. Those are all the emission devices. Drippers is another word for it. Emission devices, drippers, emitters, all the same thing. And then you finish it off with some handy tools that make your life easier. So if you're doing a new installation of drip, so especially like somebody who decides to do a turf removal program, so you want to not just change out that little planter section, but you want to do a whole turf removal program, then if you won that lottery, like, then you may want to put a whole new valve assembly in. And the valve would be especially designed for low flow. It would have its own filter regulator in the bag, very easy to install it or to have a contractor install it. One of the things in the movie, the video we saw, they talked about, that sometimes you can adjust things by turning this device here, which is the solenoid. And when you do that, you get this kind of dry operation. The sprinklers pop up, but you don't get wet. So that's a nice feature to it. Another feature they didn't mention in the video, but it's great for maintenance, is this little screw right here, which is like it's called a bleed screw. And you twist that, and you're going to get flushing right here at your feet. So if you turn that, step back, because it'll flood right here, come right out of the side and flood. And that's great for maintenance. And what's happening is inside here, there's a special diaphragm. It lifts up. It lets debris pass. So if you've done some repair, you'll want to use something like the bleed screw. So a couple of different options. This device right on the side is called a bleed screw, and this is the solenoid, so that's called an internal bleed. So external bleed, internal bleed, if I turn the solenoid. So if you're doing a new installation, you want to buy these all-in-one kits set for the valve. But as I mentioned, your savings are going to come from that sprays to drip conversion. So there are products available with its own filter regulator. I'll hold this up. So in this sprinkler, I actually have a device that has a filter and regulator in there. So what I would do, if this was my area that was sprays, I would remove the innards and then drop in, cap off the other ones, and then drop in this retrofit kit where it has its own filter regulator. Yeah, I know, it makes life so much easier. And we're going to talk about this in more detail. There are even caps for different manufacturers, so you can leave your sprinklers in the ground and then cap off all the other ones.
I was going to say, is there a ratio where I see you cap the valve, the sprinklers around the one that you've now converted into a drip system? There's some ratio that you would be able to, without measuring the pressure to that particular valve?
So you would cap off all of them. You'd convert the whole thing to drip, that whole zone to drip, that whole valve to drip. So there are all-in-one kits available, either through an online store or local distributor. This was created from a study I did with Western. We went to 20 homes. We looked at those planter sections that were sprays. We measured how much water was going through there first and how much they were using. Let's say they were running the system for 10 minutes. We figured out how much water we were using, reading the meter. Then we removed the innards, capped them off, dropped in this retrofit kit, ran the tubing, measured again. Guess how much water is saved on that valve? About 80%. They actually saved 80%. I know, amazing. Actually, those houses would have saved more water if they had used pressure regulation and done the check valve. Because that's the difference, but still making this conversion makes a big difference. So those would be, you know, some of those big factors. I have a question over here.
Could you back up one slide so I can get the model number of that cap? Because I need those.
Okay. These are the model numbers for the caps. Oh, they're new.
I'm sorry.
That's okay. No worries.
Okay, thank you.
So an all-in-one kit's available. And as I mentioned, pretty easy. Remove the spray head, drop in the retrofit kit, attach the tubing fittings, cap off the rest of them. And the kit has all the fittings, everything you need to do the job.
Is there a rule of thumb on what those kits sell for?
Yes, they are about $199. And some water districts will do programs where you come in. I do a whole class for about an hour, hour and a half about how the kit works. We play with the fittings, and then you're either able to get it for like a really good discount, or the water district might give it away. So it's a drip kit program. I'd say just ask. I have a question over here.
Yes, I have a question on that valve that you showed with the pressure regulator and the filter and everything already in it. But you're saying for new installations, but if you have an old one that you've converted, would it be advisable to, I mean, I'm thinking, but I don't know how much those run, the whole valve to exchange out an old valve, because I converted, I have no lawn, I just have planter areas. So I converted everything to drip myself, but I put like those little tiny external pressure regulators and stuff that you put in the line and everything, and my drip heads are constantly blowing off in the front yard. So I'm just wondering if it might be better to exchange out the whole valve instead.
You know, if you can, that's a good way to go, because that way you get the filter and the regulator. But as a rule of thumb, most times if you check with the manufacturer, your existing valves should be able to operate at these lower flows. And you're looking for something that on the website, it'll say, oh, here's my valve. You take a picture of it and go, oh, that's what my valve looks like. And it'll say it operates at something like 0.2 gallons per minute, which is converted to like 12 gallons per hour, Or it might say, most of these residential valves will operate at 0.2 gallons per minute to about 2 gallons per minute. So that's really somewhere between 12 gallons per hour emitters to 120. So as long as you got enough tubing out there with emitters, or you switch them out. Especially if you're going to do that little, when sections one valve, you know, you might want to update it, or if your valves are kind of old, you may want to do it anyway. But you will know you have to switch it out if the symptom that you're going to see is that the valve won't shut down. So you put in the system, and you have the drip, and you run it for 10 minutes, and then you think it should be, except for, you know, kind of dripping for a few more, you know, minutes after that. But if it's like 5 minutes later, 10 minutes later, and still dripping, and it obviously hasn't shut down, then you're going to have to replace the valve. So the valve can't operate at that low flow range. I have a question in the back.
You mentioned about valves being old, and I'm wondering what you mean by that. And what is the life of a valve generally, and also sprinklers?
Okay, so you're asking what's the life of a valve. I mean, valves can live a long time. 10 years is not uncommon. Valves are pretty nice because you can change out some of the key components. Valves are pretty basic. So basically, you're either going to change out the diaphragm component in here or the solenoid. And in the troubleshooting section, I'm going to talk about that in more detail. So they should be able to go a long time. Now, the sprinkler bodies themselves can also last a long time. Some of the newer technologies have improved. This is usually a fail point on a sprinkler where you get what we call it flow-by, where this white area kind of breaks down, and then as it pops up, it's also spraying up through the nozzle and out of the sides. Then it's time to replace, you know, the top of it. Yeah, that's time to replace it. But 10 years is not uncommon. They should last a long time. So in summary of this technology, we're going to go from sprays to drip. I'm going to take a deeper dive right now as we talk about drip and the different components. We talked about point source irrigation for the sparse plantings. And that can either be emitters into the tubing. And what I recommend for drip irrigation, the emitters into the tubing, if I'm your plant, I'm going to have my emitter start halfway between my canopy. So halfway. I would have 2 emitters. I'll get a question in the back. So 2 emitters. The flow rate I would consider is, if it's a 1 gallon, I would have 2 1-gallon emitters, 1 on each side of me. I have a question in the back.
I can't see when you demonstrate because of the monitor there.
Okay. Sure. Okay. In fact, lovely Lisa will help us. Okay. So we'll just hold that up. Okay. So on the bottom is your kind of emitters. As I mentioned, you have a 1-gallon plant. You have 2 1-gallon emitters. If I had a 5-gallon plant, I would have either a couple of 2, let's say like 3 or 4-gallon emitters, 5-gallon emitters on each side of a 5-gallon plant. If I was a larger plant or tree, I might have 4. Okay, so that's point source. On the top, way at the top, with those black things sticking up, that's an example of a polyflex riser approach. How many people go down to the desert, Palm Springs, Palm Desert, those areas? Now, how many people, when you come to a stop sign, do you look out and see how do they do that irrigation? Okay, yeah. So, and that's what you'll see. You will actually see those black pipes sticking up, and then it'll stop just under the plant, and then the plant will be above it. That's polyflex riser. That's a desert install. That does really well with, you know, if you have rodents and it's a nice desert. These are examples of spars. Now, another type of irrigation, I call it the Marietta install, and it uses these threaded bubblers, which is on this row right here. Threaded bubblers that either could be into the, actually could be into the pipe, or you can use something like this, a flexible pipe. I call this a Marietta install. I mean, people drive down to Marietta and Temecula, and you'll see PVC and then see this kind of black hanging down, and then these are at each one of the plants. Okay. Yeah, so that's a That's a different kind of swing assembly, swing pipe, also called funny pipe. And we're putting an emitter, a threaded emitter on there. Okay, that's your kind of your sparse planning. In your dense planning, probably for the most part, you're going to go with drip line tubing, and it has these factory installed emitters in there. They're spaced. I recommend spaced every 12 inches, and I recommend your highest flow rate might be 0.9, might be 1 gallon per hour, something like that. And then you're going to do it in a grid. So this is your dense planning. You're going to water the entire area in a grid. 12-inch spacing, very easy to do, and very practical. And then you basically, in scheduling your drip, start with a schedule of your current spray system. Just start there and see that works. Because you're probably giving it 5 to 7 minutes, and this will also cover that area in about that amount of time, maybe a little bit longer. Yeah, question?
Is that recommended on a slope?
There are versions that have check valves in it, emitter that has a check valve part of it, and you could put that on a slope. Yeah, so like a check valve version of drip line tubing. And the manufacturers have it, have this kind of stuff. Question in the back.
Do you have to make sure that your landscape is flat when you're laying that out? I mean, you can't.
So you can lay it down in a grid, or you could go with blank tubing that looks kind of like this. It's over, oh, this blank went on the bottom. You can go combination, blank tubing, and then you punch in emitters, or you go with drip line, and either one you can kind of snake around if you wanted to. So you could have it on the blank tubing, get the tubing right near each of your plants, or you can do a grid, or you can snake even this drip line, or you could add additional emitters. Very flexible. Drip is very forgiving. Now you just move it around. Let's see, what else did I want to tell you about this? So definitely, the one area is definitely thinking about that spray head area, that's planter, shrubs, and basically improving that, converting that to drip. And that project with an all-in-one kit's, a couple hours. It's pretty easy to do. Most people can do it. What do you guys think? That question back? Right. So yeah, if something breaks, which kind of does, then you basically take depending on how big the break is, you either put a fitting in there, a coupler in there, or you put a fitting, a little extra tubing. So it's very forgiving to do a quick repair on drip. Other questions about drip? Oh, questions in the back. Are you referring to these multi-outlet device manifolds? Okay.
You have tubing of different kinds.
Okay.
Right now, what I do is, get a little cage, make a little cage out of chicken wire or something, but that's very labor intensive and kind of tough, whereas if they had a better manifold, with kind of a cap on it, that could be pried off after you use it, if it connects to various tubes, that'd be very nice. And you would eliminate a huge amount of damage.
Okay, so when we take a break, or at the end of the session, you can come up and see the 2 manifolds I have. One is like a spaceship, and it's everything self-contained in there. Bringing up a couple good points that I want to share with you. When we talk about the tubing, and then what Lisa's holding up is considered a 1/2 inch. But 1/2 inches are different, so that's the ID and the OD, is a 1/2 inch tubing. But different manufacturers have different dimensions. So whatever you do in your 1/2 inch, you buy the same manufacturer tubing and fittings. Otherwise, it'll be really hard to put on, or it'll fall off. They're different dimensions, don't know why that is, just started that way. So half-inch, same manufacturer fittings. Now, some of the things that have been problems over the years is people's use of, we call it quarter-inch tubing, and it's also called spaghetti tubing, because the gophers and rabbits think it's pasta, they eat it. So what I recommend is that if you do a device like this, these multi-outlet manifolds, multi-outlet devices, that you keep your quarter-inch, think of me and keep it under 5 feet. It's not a hydraulics issue, it's a maintenance issue. The better way to go is to take your half-inch and snake it around to as many plants as you can. And if you have to, you may use quarter-inch, like if you were doing a container, sneak around your half-inch, and then into your container would be a quarter-inch, and then go with drip line that's meant for quarter-inch, like inside a container. That does a really good job. I have a question in the back.
Actually, it's just a comment, because I have my whole property is, the black colors and irrigation, and I was having a lot of trouble with that too. So what I did was I put little watering stations for the animals, like just little clay pots buried in the ground, plug the bottom up. And I made sure I had a dripper that went in, and enough water went in every time it watered, that the water overflowed a little bit. So the water is nice and fresh. And I haven't had any trouble since then. I just got these little watering stations, and I've seen everything, even lizards. I put rocks in it so the lizards don't go in and come out, But I haven't had any trouble except over the winter. This last winter, I completely turned my water off and my watering stations dried out. And then I had a couple of lines that were chewed. So I don't know if it'll work for everybody, but it really worked.
So it's a great suggestion. Also, there's literature on the Master Gardener table about dealing with like rabbits. There's one on gophers and things like that. So take advantage of the literature that's available. And our last area is really important. That's the maintain, troubleshoot, repair. So in your book, there's troubleshooting section, page 100 to 104. Let's take a look at 100. I will also have it on the screen as well, but looking in your book would make it easier. So what we've tried to do in the book is to give you some of the major problems that you could have. And you'll notice we have, the problem in this case is water won't turn on, what might be the cause, and then possible solutions, so that you would know, how do I know in the valve, is that the diaphragm problem or is it a solenoid problem? Well, that's how it'll kind of guide you to some of those options. And then on the bottom, we talk about things like doing the zone-by-zone review. And if you remember in the video, that's what we did. We went and did that pre-audit. And so that's what this is, again, leading to and discussing, is the idea that you should, while we're doing our test, we should go zone by zone and look for leakage, look for problems, look for things like, is the plant, is the sprinkler popping up and the plant's in the way? Okay. So another research that was conducted about 10 years ago by our Master Gardener advisor, Dr. Harton, she did a study with a group. They went to 30 sites in the Inland Empire. One of them was Pachanga, golf courses, school districts, parks, and all they did was they measured the water usage before. They just did maintenance. They didn't change out smart weather-based controllers. They didn't change out all the nozzles, other than if they were different manufacturer nozzles, they went to the predominant nozzle that was there and put those in, made sure the heads were aligned. Made sure the heads were facing watering the way they're supposed to be watering. Went through and did all of those different functions, all of the maintenance that you saw like in the video, and those sites saved, altogether, saved 30%. Some, like golf courses, are pretty efficient, so they saved maybe about 10%, but some parks, older parks, were like at 50% efficiency. So, just doing the fundamentals could really save you water. Just doing the repairs, use these guidelines, and you can definitely be hunting for water savings. Take advantage of the troubleshooting guides as well. So, when it comes to the technology of maintaining and troubleshooting, refer to the troubleshooting section of this book, watch how-to videos, and sometimes it's worth hiring a contractor specializes in this. Very fortunate, some of the water districts like Western, if you're getting water from Western, You can go online to their website and request a person to come out and give you advice. So take advantage of that. Guy's been doing this for years. He's going to give you the straight talk on what needs to be done, what rebates are available, and so that makes sense. Or take advantage of contractors that specialize in this kind of work.
Is there a list of contractors around the area that specialize in that? Do you have a list available?
Not really a list. One thing you could do is go to a local irrigation house and let them know what you're looking for. They know the contractors that like do turf removal, or the contractors that do repairs. You know, they know who these guys are, and that's the type of work they do. So they'll give you this, you know, some good people that they know. So we talked about 6 key strategies. We talked about improving to weather-based controllers, or at least getting some features on the controller that will save us some time. Flow sensing and leak detection, really critical. Optimal pressure, so pressure regulation. High efficiency nozzles, the sprays to drip planters, and then the importance of maintaining. So let's have a discussion. First of all, why would we even consider the time and effort to improve our irrigation system? What are some of the benefits? Saving water. Keeping your plants alive. Saving money. And now, as a result of talking about all these areas, what do you plan to do in your yard? Walk it. Good. Who's going to do the homework assignment? Okay. Yeah, I think it's worth doing it and looking for problems. Who's thinking about a smart weather-based controller? Yeah. What about improving the nozzles, the heads? Can you change the light bulb? Then you can do that. That'd be a good one to do. Okay. So water-efficient irrigation, healthier plant material, less disease and plant loss, shorter irrigation run times. We're not overwatering to compensate. Less water waste as well as less runoff. Lower water bills. Sites are easy to maintain. Less use of fertilizers and pesticides. Healthy plants then don't require to use chemicals. And it just makes you a better steward of the environment. Not only is there the book, but there is a website that's tied to it, SoCalYardTrans.com. So you could go there. We're trying to put on additional videos and links to other additional information. That's a great resource. Another great resource is bewaterwise.com or SoCal WaterSmart, where you can get rebates from, taking advantage of those information. Another great idea is, especially if you're thinking about you want to do improvements to the yard like turf removal or some other things, or add different plants, more California-friendly natives to your planter sections, then walk the neighborhood, see what plants are doing well in your neighbor's yard and what you like, and then you could buy those. If they're doing well in your neighbor's yard, they're probably going to do well in your yard. So take a look, take advantage of demonstration gardens, places like Descanso Gardens, be inspiration of improvements to make. Question? bewaterwise.com is another great resource, or you can get there from SoCal WaterSmart, where we get our rebates. And if you have questions, I'm going to be able to, we're going to do some drawings in a minute, but I'll stay here and do the hands-on with you after we do the drawing. This is my email address, so I certainly can, if you have questions afterward and you want to email me, I'm happy to help you out. The Master Gardeners are here, and they're a great resource. I'm the expert on irrigation, but I don't know plants as well, so if you have plant questions or the rabbit questions, they have literature on that that can help you out. So take advantage of great organizations like the Master Gardeners. It's definitely, if you like gardening and plants and irrigation, then that's a great group to be with. Let me see if there are final questions. I have a question in the back. Solar controllers tend to be at the commercial level, so pretty expensive, But there are battery-operated controllers. So if you don't have power, you could take advantage of a battery-operated. The batteries only last about a year. You have to replace them. Okay. Remember to, my advice is to always go to a professional irrigation house and get kind of the contractor grade on some of those things. And definitely the good advice from the distributors. I had another question? Okay, question over here.
On the drip line, you said, let's say it puts out a gallon per hour. How many feet is that over?
Yeah, each emitter puts out a gallon per hour. But that does raise a good question, kind of a rule of thumb for most, you know, like if you're going to get a kit or you're going to get so many feet, basically a gallon per hour, spaced 12 inches, you can go 250 feet in either direction. So you can get quite a bit of run on that. You know, on the charts themselves, you can go to the manufacturers and they'll actually show exactly how much it is, but that's a good rule of thumb. Was this helpful? Do people feel better? Okay.